This is Unit 3, Lesson 1, Day 1. We're going to be learning about something called piecewise functions today. So in this first set of lines, we just have a quick definition that we're going to write down. So a piecewise function is made up of two or more functions. Each with its own domain. Okay, so each with its own domain. Remember, a domain is a set of x values. So you can see a couple examples right here with number 1 and number 2. First thing we're going to do is just learn how to evaluate them, kind of play around with what exactly that domain part means. So if you look at this first one, for example, this is the typical notation that you'll see. You'll see the function notation on the left. You'll see these big squiggly brackets. On the inside, you'll see 2, maybe 3 different functions. So there will be an equation on the left, very typical, just like you've always seen. And then it'll say if, and then it'll give what we call a domain. And this is a set of x values. So if you look at this first one, this is basically saying, we're going to use this function if you choose to plug in an x value that's smaller than -2. But if you choose to plug in an x value that's greater than or equal to -2, you're going to be plugging it into this function instead. So that's what the notation means. That's everything we've got going on here. We've got 2 of these, so we're going to look at number 2. Make it a little bit more complicated. So we have g of x, and then we have 3 separate pieces. So we've got a linear function, another linear function. This one's called a cubic function. We have an x cubed. And we've got 3 different domains. 1 if you're choosing an x value that's less than or equal to -4. 1 if you're choosing an x value between -4 and +1, but not including those numbers. And then 1 if you're choosing something greater than or equal to 1. So when you evaluate them, g of -2, normally that notation means you take the number 2 and you plug it into your function g. And that's still what that notation means, but you have to make sure you know which piece of it you're supposed to be plugging into. So you look at the 2 and you see which of these 3 categories it falls into. It's not less than or equal to -4. It's not between -4 and 1. It is greater than or equal to 1. So that means we're going to take our 2 and we're going to plug it into this expression right here. So 2 and then x cubed, that's where I plug the 2 in. 2 cubed plus 9. So we follow the order of operations. 2 cubed is 8. Then multiplication, 2 times 8 is 16, plus 9 gives us an answer of 25. So when I plugged 2 into this function, I figured I had to plug it into the third piece because of the domain, and it came out to be 25. Next one, -1. -1 is not less than -4. It is between -4 and +1. So the -1 gets plugged into this middle piece. So we have -x, so that's where my -1 gets plugged in, and then -1s. So a lot of ones, a lot of negatives. So let's be careful here. So this is a -1. So that's a 1. And then -1. So of course 1 minus 1 just comes out equal to 0. That was my second piece. And part C, we're going to do the very same thing one last time. We have a -6, so let's look at our domains. It is less than or equal to a -4, so we get to see one of each. -6 is less than or equal to -4, so it gets plugged into this first piece. So I have 1/2 x, that's where I plug in my -6, plus 3. So do the multiplication first. Half of -6 is a -3, and then when I add 3, I actually get 0 again, which I just got for part B. So that's how the evaluating works. That's how the domains work. That's how you figure out what's supposed to go where. The other section that we're going to be looking at is graphing piecewise functions. So I'm going to walk you guys through exactly how that works. So we have 2 different graphs that we need to plot. So f of x looks like the graph of x only for these x values. And then it looks like the graph of -2x plus 1 only for these x values. So I'm going to show you exactly what that's going to look like. One thing that's very important when you're graphing these, you want to make sure that when you initially graph them, you do it in pencil. because when we graph it, we're not going to end up keeping the entire graph. We're going to erase the part that doesn't fall within this set right here. So I'm going to graph x. Sometimes it looks too simple for people to know what to do with it, but what x is, it is a y-intercept of 0 and then a slope of 1. So it's still technically mx plus b. It's just kind of like 1x plus 0. So this one, I'm going to start at the origin with my y-intercept of 0, and then it has a slope of 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, and do this just quickly a bunch of times until we reach the end of our grid. And then remember, slopes can be reversed as well, so we can go off in the opposite direction, down into the lefts, and just quickly go through each grid. So this should go from corner to corner of this entire grid. Now this part, when I graph, like I said, it is very important that I am just lightly doing this in pencil, because until I look at the domain, this is not finalized yet. So this is just what the graph of x looks like. But then we look at the domain part, it says if the x value is less than or equal to -3. So that means we've got a bunch of points plotted on here that we're not actually supposed to use. Like this one over here has an x value of 1. We're not supposed to be using that because it doesn't fall within this range right here. So what you're going to do is we're going to find that x value of -3. So here's 0, -1, -2, -3. So if we trace to the graph, that means that's this point right here. So this point has an x value of -3. I want to keep the ones that are smaller than that. I want to keep the -4, the -5, the -6, but anything bigger is not supposed to fit in this piece of the graph. So this is why I told you guys to do it in pencil. So we want to erase the rest of this part. I'm going to erase anything that doesn't fit with what the domain is supposed to be, because I'm not supposed to be plugging in a -2, a -1, 0, or anything bigger. So then once you're confident about that, then we can actually connect the dots and make this just one piece of a line. That's what we call it, a piecewise function. Last little detail is this is less than or equal to, so I put a closed circle on that point, and then all the values that are less than -3. So this extends off to the left, which means it hits -4, -5, etc. So that's the first part. We're going to do the exact same thing with this second part. So second part, this has a y-intercept at 1. And then it has a slope of -2. So from here I go down 2 to the right 1, down 2 to the right 1, and then just keep doing that until we run out of space on our grid. And again, remember you can reverse as well. So we go up 2 to the left 1, up 2 to the left 1, until we run out of space here. So very important again that we are doing this in pencil first. Looks like that. So there's the full line. We only want a piece of it though. We only want the piece where the x value is greater than -3. So -3 is kind of our leadoff point again. So find -1, -2, -3, trace to the graph. So we only want the x values that are bigger than this, which means we only want the part to the right. So I'm going to erase anything before that, which isn't much on this grid. Last thing is this is just a greater than, so I actually don't want this point there. I'm going to put an open circle, because that's what the greater than means, is it's not a closed circle. So this is what our graph looks like right here. All right, last thing we need to do for each of these is identify the domain and range. So for the domain, you can just kind of look at these pieces right here. This covers everything less than or equal to -3, and then this jumps right in and covers everything greater than 3. So the domain is all reals. Every single x value gets covered, and you can see that just by looking at these two pieces. Next, the range, you want to talk about the y values and what y values get covered. So for that, you'll have to look over at the graph. And I like to just kind of scan up and down, see is there a lowest value, a highest value, do any values get skipped? So because of these arrows, there's no lowest value. And no values get skipped, because even though this graph ends, this graph picks right back up in terms of y values, but then it stops here. This is your highest possible y value. And if we count up, this is 1, 2, 3, 4, 5, 6, 7. So our graph never goes any higher than 7. So what we write is this: y can be anything less than 7. Just a less than, because it's an open circle. So that is what our first piecewise function looks like. We're going to see a couple on the next page, so we'll get an even better idea of how to do these. So let's look at number 5 on the next page. So very similar here. We've got two different pieces, so let's practice this again. So this one, we're gonna graph the full thing in pencil and then erase what we don't need. Y-intercept is in a -1, and then our slope is -5/2. So I'm gonna go down 1, 2, 3, 4, 5, over to the right 2, and I'm out of space. So I can also go reverse it, go up 1, 2, 3, 4, 5, over to the right 2, and I do run out of space before, I'm sorry, it was the left 2. I run out of space before I can get up 5 units again. So I'm going to just sketch this in. This is the full line, so I'm doing it in pencil because I'm gonna have to erase part of it. And I want this part for x values that are less than 2, or x values to the left of 2. So find the 2. Here's 1, here's 2. Here's where that graph is right here. I want to keep everything to the left of that point, which means I need to erase everything to the right. So get rid of this. And then look at the inequality. This is just a less than, so I need to erase that point itself, and I'm going to replace it with an open circle. Then I go off to the left. So all the x values that get covered here are smaller than 2. The ones that are bigger than 2, I erased. Next piece, x plus 2. So plus 2, that's my y-intercepts. And my slope is 1. So I go up 1 to the right 1, up 1 to the right 1. You can follow that pattern really quickly because it's just hitting all the corners. And you can also reverse and go down into the left. You can do that pattern really quickly too. Okay, so in pencil, we connect the dots to see what the full line looks like. And then we're going to erase part of it. So we want to keep the x values that are greater than 2. So find the 2 first. 0, 1, 2. That point has an x value of 2. And I only want to keep the stuff to the right. So that means I'm going to erase everything to the left. Now remember, the greater than or equal to is not up or down when we're talking about x values. We're talking about left and right. And then the greater than means this should be an open circle, just like the first piece was. So at x equals 2, I have an open circle, and then my graph only goes off to the right. It happens to go up, but that's not the important part. The right is the important part. All right, domain. We look right here. We have everything less than 2, everything greater than 2, but we don't actually hit the 2. Neither one of them has the or equal to. So for the domain, we write x cannot equal 2, or x does not equal 2, I guess. And what that means is that everything besides the 2 ends up getting hit at some point. And you can see it's left out because neither one of them has the or equal to. So everything but 2 gets covered. You can see that there's a hole where this x value never actually gets hit. The range, we look for minimum, maximum, any gaps. There is a minimum. This is the lowest possible y value our graph will ever hit. Never goes below here. There are no gaps anywhere, and there's no maximum because these arrows just keep going up. So this is the lowest possible y value, and it is -1, 2, 3, 4, 5, 6. So my y value can be anything above that -6. All those y values will get hit. All right, let's look at one more of these. Let's do number 7. Number 7 has 3 pieces. First piece is a 2x, so that one has a y-intercept at 0, and then a slope of 2. So I go up 2 to the right 1, up 2 to the right 1, till I fill in that whole grid. Then back to the origin, I can reverse, down 2 into the left 1, till I run out of space there. Connect the dots in pencil till I figure out what part I'm going to keep and what part I need to get rid of. The part I'm going to keep are those x values that are less than or equal to -2, or to the left of -2. So here's -1, -2. That's where my graph has that x value. So I want to keep the part to the left, which means I need to erase everything to the right. And this is less than or equal to. So at -2, I'll have a closed circle, and then my graph goes to the left. It also happens to go down, but remember, down has to do with y. X has to do with going to the left. Next is this piece. It's out of order, but this is your y-intercept, your -1. And then the negative in front of the x is your slope. So you go down 1 to the right 1, down 1 to the right 1. Remember, with that, we can just quickly go from grid to grid and fill in that pattern. And you can also reverse up into the left. So we got a lot of points here. Sketch it in pencil. So now let's see what we're gonna keep. This part's a little tricky. So this is called a 3-piece inequality. This says we're gonna keep everything between these two x values. So I wanna keep everything in between a -2 and a +4. So let's find the -2. -1, -2 is here. So if I want everything in between, that means I don't want anything before that point. And then I wanna go up to 4. So here's 1, 2, 3, 4, which hits the graph right there. So I want everything in between, which means I don't want anything after 4. So nothing before -2 and nothing after 4. I just want the part that's in between. So it ends up being this little segment. And last thing, these are both open intervals. So I put an open circle right here, an open circle right here, and then connect the dots. So we can erase that little pencil mark in there. There we go. All right, and last piece, -3. So -3 is like a y-intercept. So I go 1, 2, 3, and then there is no x, which means there is no slope, and that means that this is just a horizontal line. So that is a horizontal line at -3. Okay, last erasing that I need to do. I only want to keep this when my x value is bigger than 4. So let's go to 4, 1, 2, 3, 4. That meets the line right here. I want to keep everything to the right, which means I want to erase everything to the left. So we got a lot of erasing right here, which is why a pen is a good idea to kind of darken everything up. So there is a closed circle, and then I keep everything to the right. So that's what my 3-piece graph looks like for number 7. So let's fill in our domain. So if we look, everything gets hit. These all have our or equal to's, so nothing gets left out the way it did with number 5. So none of the x values get left out, so it's all reals. With the range, let's see, there is no minimum because this keeps getting lower. There are no gaps because anytime one of them stops, the other one kind of picks up right here. And even though like this looks like a gap, those y values are covered over here, then this point is the maximum. This is the highest y value that my graph hits. There's nothing up here. And this y value is +1. So I say y can be anything less than or below +1.